You know that feeling when you're on a website and it just freezes? You can't click anything, you can't scroll, you're just stuck, waiting for something to load. Well, the secret to fixing that, the real magic behind the modern responsive web, is a little something called a callback. So today, let's pull back the curtain and figure out what these things are and why they are so incredibly important.
Before we even touch a line of code, let's start with this analogy because it is just perfect. Picture it. You're at a super busy restaurant. You place your order. Now, do you just stand there in the kitchen staring at the chef until your food is done? No way. Of course not. That would be a huge waste of time. Instead, you give them your table number, right? A way for them to call you back, and you go find your seat. You can chat with your friends, look at your phone, do whatever you want. And then when the food's ready, they bring it to you. That's it. That is the fundamental idea of a JavaScript callback.
So why do we even need this whole restaurant system in our code? Well, it all boils down to solving a really big problem in JavaScript, what I like to call the waiting game.
Okay, take a look at this slide. It shows the problem and the solution side by side perfectly. On the left, we have what's called blocking code. This is like calling a friend and your entire life stopping until they answer. The program can't do anything else. It's just frozen. And that's exactly what happens to a web page. But now look at the right side. This is the non-blocking way. We still call our friend, but we also give the program a little note, our callback, that says, hey, when they answer, do this. The crucial difference? Our program doesn't wait. It moves right on to the next task. It can multitask.
And here is why this is such a huge deal. At its core, JavaScript is single-threaded. The best way to think about this is like a single-lane road, or maybe a grocery store with only one cashier open. Only one thing can happen at a time, period. So if one car breaks down in that lane, or one customer has a million coupons, the entire line grinds to a halt. Without callbacks, any slow task, like fetching data from a server, would be that broken down car, freezing everything behind it.
So how do we keep that line of traffic moving? How do we create that smooth, seamless experience that users expect? Well, this is exactly where callbacks come to the rescue.
Let's look at how a real modern web page actually loads. The basic structure pops up, right? But look, almost instantly the page is interactive. You can scroll, you can click on things. Why? It's because the really heavy stuff, like loading that giant hero image or fetching all the product data, was kicked off with callbacks. Those tasks are happening in the background. The browser doesn't wait for them to finish before it lets you start using the page. This is precisely why the modern web feels so fast and fluid.
Okay, so we've seen the restaurant analogy, we've seen the problem they solve, but let's get down to brass tacks. What, technically speaking, is a callback?
You know, it sounds way more complicated than it is. It's really just this simple four-step recipe. First, a callback is just a function. Nothing special about it. The magic happens in step 2. You pass that function as an argument into another function. And why would you do that? That's step 4. So it can be called back and executed later, whenever that first function is finally done with its job. That's the whole thing. It's a function you hand off to be called back later.
And to really cement this idea, just think of a callback as a phone number. You give it to a friend and say, hey, call me when you get there. You don't just stand by the phone waiting, right? You go about your day, and you know they'll call you back when they're ready. It's the exact same principle. Now that we've got the what and the why, let's talk about the real-world impact. Because this isn't some obscure programming concept. You literally experience the power of callbacks every single day. Just think about using Gmail. You're typing up a response, and at the same time, in the background, Gmail is checking for new messages. That's a callback at work. Or think about YouTube. You're watching a video, but you can scroll down and read the comments. All the while, the player is busy buffering the next few seconds of video in the background, using callbacks so that your playback is perfectly smooth. That seamless multitasking? That's the signature of a modern web app powered by callbacks.
And if you're wondering just how common this is, get a load of this number. A typical modern web app makes somewhere between 50 and 100 of these asynchronous, non-blocking calls for a single page load. Every single one of those is an operation that, without callbacks, had the potential to freeze your entire screen. That's the massive, massive scale we're talking about here.
So we pretty much established that callbacks are the unsung heroes of asynchronous JavaScript, right? They keep our app snappy and our users happy. But this does lead to a new, pretty interesting challenge.
This brings us to a really crucial question. If one callback is great for handling one task that takes a while, what happens when you need to do another task but only after the first one is done, and then a third task after that one is done? Well, you end up with a callback nested inside another callback, which is nested inside another callback. It can get messy fast. And that raises a fascinating question about how we manage all this complexity. a puzzle for another time.